All right, so now we're going to talk about real-life batteries. So a battery works by a redox reaction, most batteries anyways. They do have rechargeable ones now, but most batteries work by a redox reaction. I know you missed my drawings, so here you go. So this is the reaction. Copper plus 2 plus zinc solid turns into zinc plus 2 and copper solid. Is this a redox reaction? Yes, it is. Why? Because our rules tell us that anything with no charge on it all by themselves is going to take the charge that's on it. So zinc is 0 here, and here it's plus 2. Here copper is plus 2. Here copper is 0. So if I'm going from plus 2 to 0, I'm going to gain 2 electrons. And if I'm going from 0 to plus 2, I lost 2 electrons. So, if zinc is the one that's losing the electrons, that is where the source of my electrons are coming from. Here is my reaction. My source of electrons in this reaction is coming from my zinc. So here's my zinc. I have two little sections. I need to draw I would draw just a rectangle. It's got liquid in it. And here is my solid zinc. It's a solid, and that is my source of electrons. So the electrons are coming off of the zinc and going to the copper. And that ends up being a copper solid. So this is a solid and this is a solid. So here you have to have Cu floating around in here, but my zinc is what's giving you the electrons. So the source of electrons is going to be your anode. Anode. So maybe you've heard of anode and cathode before. So your anode is your source of electrons. That's your negative side of your battery. You've all seen a negative and positive side on your batteries before. So your anode is your negative side. So here, the zinc is what is providing the electrons. So that's your anode. Your electrons are flowing this way. So they have sometimes a little voltmeter on there to show you which way your electrons are flowing. But then they're flowing into the copper. So the copper is what is reduced. It gains the electrons. So that is originally positive because that's your cathode. So your electrons are flowing from your negative side to your positive side. And then you also have to have this here. This is called your salt bridge. You don't really have to worry about how that works. Just know that it just like if water would flow one direction, eventually it would fill up and it would stop flowing. So you have to have a way to dump your electrons back in your battery so that it continues to flow. So a salt bridge brings the electrons back. You don't have to understand all that. Just know that there has to be a salt bridge there. So you're going to draw the source of your electrons is your anode. The positive side where the electrons are flowing is your cathode. You have to have those labeled. You have to know which one is oxidized, which one is reduced, and you have to have a salt bridge. So you're going to show me that my electrons are flowing from the anode to the cathode. You can just draw a little arrow, and that is how your battery works. So let's do example 16.5. A galvanic cell runs on the following chemical equation. So it's going to be exactly the same picture, only now we're going to change, oops, that's still cathode. So we have 2 Ag positive plus Mg solid turns into 2 Ag solid plus Mg2 plus. Well, I know that this has a positive charge, so this is going to be plus 1. Mg is going to be 0. This has got no charge on it, and this has got a 2 plus charge on it. And there's 2 of these. So my this is going from positive to plus 1 to 0. So I am gaining electrons because I get less positive or more negative. Here I'm going from 0 to plus 2. So I went from 0 to positive, so I lost electrons. So I have to say that my silver was oxidized, or I'm sorry, reduced, and my magnesium was oxidized. So here we have a loss of electrons is oxidized. Here we have a gain of electrons that's reduced. So when I'm looking at this, this is what's losing my electrons. So I'm going to label this Mg, and I'm going to label this Ag. So my anode is Mg, my cathode is Ag. My electrons have to go this way, and make sure that you draw your salt bridge. Okay.